Okay, we're going to start a quick video this morning concerning the Stirling hot air engine. Just going to be a quick update. I've been progressing on this slowly but surely. There's a number of parts involved. I was counting up parts this morning, and of course there's some optional things which I discounted, but even taking away the optional items, there's 38 individual parts that go into this little engine. So it is a bit time consuming, although when you look at the overall engine assembled, it looks quite simple. Anyway, this morning I'll swing the camera around this morning. I'm not showing any CNC work on camera because it takes time. I have to fast forward it, and it really is kind of monotonous. So this morning I cut out the weight that goes on the web, and I'll explain that when we look at the engine. I've done a few things to it. Basically, I've cut out a few parts on CNC, which I'll show you, and they are still unassembled. And yeah, you know, I put the parts together that we talked about last time. We had a bunch of parts that we cut out with CNC and so forth and so on that needed soldered, soft soldered, or silver soldered together. So I did that part off camera. So anyway, that's where we're at. So I'm going to swing the camera around here a couple times, and we'll talk about the engine in its entirety. So let me swing the camera around here. I don't know how far I can zoom in on this. My camera's quite a ways away. It's about 7 or 8 feet away. But you'll get a better look at this in a few minutes. So there's what we just did this morning. It only took a few minutes, a little over 15 minutes to cut out the weight. There's some interesting information I'd like to give you about the weight, but I'll do that in a few minutes. I'm going to swing the camera around to the bench, the little workmate that I have set up over here, and see if I can find it here. I'm all over the shop here. So there's the engine. You can see it in the background there. And so we're going to talk about that this morning. Let me swing that around. Get a better view of it. So you can see there what I've got completed so far. Basically, I've just started assembling it a little bit so I can work on it. Well, there you go. Actually, that's a pretty good view. Let's see. Last time, I think we had all the main chamber out there, the water jacket, and the displacer. All of those items were in pieces. So now they're all assembled and soldered together. I'm not sure whether we had the cylinder for the piston done. That was a simple project. I had a piece of tubing that didn't require anything, and the mounting bracket that I cut out on CNC. So you can see that. And the only other thing I did off camera was make that aluminum block that everything mounts to. I don't think I had that last time. So that was a pretty simple thing. Just got a couple holes through it is all it is, and the mounting holes. So there's not much to it. there's a hole that goes between the displacer and the piston, or the cylinder there. So that's an angled hole that goes between those two. But other than that, just a square aluminum block. So that's that. And that piece you're looking at there is called the web. And those two holes in the bottom of it are where the weight mounts, the counterweight mounts. And then so we put that together, and so that's something we did since we last talked. Let me go over and show you how that goes together. So this is the crankshaft here, and there's a tube that the crankshaft runs through, and that tube, I think we had it made last time, and that tube has a couple bushings inside, and it also silver solders to the main base plate here. And then this crankshaft, let's see, let me get up a little closer. So there's the web. We cut that out on CNC, okay? It's just got a threaded hole in the middle and two mounting holes in the bottom. Those are just clearance holes for the weight. So we'll show that on this video here. And then on the back side, that thread on the crankshaft is about 1/4 of an inch long, and there's a nut on there that's threaded all the way to the end, and then this crankshaft is put into the lathe, and that nut is faced off. So it makes an absolutely square connection to the web, because that's important. You don't want any wobble there. They say this engine's no lady, so anyway, so that'll get some Loctite on the thread eventually, but right now I may have to I'll explain to you later, but the weight piece is supposed to be a piece of lead, which I've converted to a piece of brass. So I'll explain that to you when I take off the weight. I'll move it over to the bench, and in the meantime I'll shut the camera off. So that'll take a couple minutes. So let me put this back. So there that is, and the piston, you can't hear it on camera, but we've got an aluminum piston that we've created, and if you pull this piston out, you'll hear the popping sound, because it has to fit absolutely perfectly. So that's that. I haven't actually finished the piston. The piston's to length, and the diameter's correct, but there's some let's call it the wrist pin. I forget what they actually call it, but the wrist pin has to fit in there, and then the push rod has to go to it. And the two push rods are here. I cut these out with CNC. They're just a piece of 1/8 inch aluminum, okay? And that's one push rod. Now these push rods may not be exactly the right length. If they're not, I'll have to remake them. But right now I've cut them out per the plan, so we'll see what happens. And here's the other small push rod. This is the one for the piston, and this is the one for the displacer. Now this push rod gets a little extra. Oh, I dropped it, hang on. This push rod gets a little extra work. Now you can see that it's consistently 1/8 of an inch thick. What has to happen is most of this gets taken down to 1/16 of an inch thick. So I have to do a little more work to this before it's completed. But at least I did the CNC work, so it's cut out. Hopefully, hopefully the length is right. Now this one has a way to adjust the length, so this should work. This one, I don't think there's a way to adjust the length on it. I think it is what it is. The piston doesn't have to completely seat or be a perfect dimension at the end of its stroke, but it has to be fairly close. So we'll see how that works out. So with that, I'll reset up the camera, and I'll take the what do you call it, the weight off the mill table and bring it over here, and I'll show you what's going on with that. I don't have the mounting screws for that, so we'll have to just improvise for right now. I need some flathead screws, and I'll explain the reason why that is when I come back here. So let me shut the camera off for a second, and I'll bring you back. Okay, I moved the camera. I'm going to be out of the picture here, but we're going to be able to see the engine here. So let me turn it around here, since I got the camera on the other side now. So there we go. There it is. And I took the weight off of the the mill and deburred it a little bit, and temporarily mounted it on the mounted it to the web, which is connected to the crankshaft. Okay. Now all this has to be lined up with the piston and everything else. So hopefully this weight works. Let me right now I've got it temporarily mounted because I don't have the correct screws. But it mounts to the back of this. Boy, the lights doesn't seem to be good over here. Maybe it's just my viewer. Anyway, it mounts to the back of the web. You can, I don't know which way to turn my hand. It mounts to the back of the web. And I noticed that the radiuses on the bottom of the web and the radius on the bottom of the weight are absolutely perfect. They line up absolutely perfectly. And if you look at it from this side, you can see that I've got a couple of screws in there that have a head on them, right? But what we're going to put on there, what we're going to do is get a couple of flathead screws and countersink them into the weight. So that'll add a little clearance. I'm not sure we have enough clearance, but I think we do. If we don't, then I'll have to do something else. But what I've done, let me mount this, put this back on the in the tube here. Okay, and you can see the weight works, right? Boom. So that said, here's what happened on the weight. According to the plan, the weight is supposed to be a piece of 1/8" lead. Okay. So I don't have any lead, but I got lots of brass laying around. So what I did was I calculated the area at 1/8 inch for the piece of lead to see what the weight was. And then I designed a piece of brass by altering the thickness of it to to compensate for the lead. So theoretically I have exactly the right weight, but I have an additional thickness. So the lead was supposed to be 1/8 inch thick, and this is 167 thousandths. So about 42 thousandths thicker than the piece of lead. Now I'm thinking that it'll fit in there, and there's not a lot I can do. If it doesn't work, I guess I will have to resort to finding a piece of lead. But I'm hopeful that the piece of brass will work. It's going to be close, very close. Anyway, that's where we're at on this. The next step, I think, there's a steel arbor that mounts out here to the end of the crankshaft, and then the flywheel mounts to that. So I'm thinking those are the next two parts that I'm going to deal with. And then in the meantime, hopefully I got a couple of screws ordered, so they should be here next week. And I'll try to get this figured out and make sure that I can align everything and you know, to make spacers the right sizes and try to get everything aligned so the piston and the displacer are both aligned. Now this all works like glass, and I guess it needs to. The displacer has very tiny amount of clearance in this chamber, but it is clear, it doesn't rub, and so we're good there. And the piston seems good. Now if this piston works out, everybody says to make the piston from graphite. So I don't have any graphite bar rod laying around to do that with. But if the aluminum piston works out okay, there's two options actually for this engine. One option is the solid piston, which is the easiest thing to do. So that's where we're at right now. Another option is a lightweight piston, which is hollow inside, and that's another possibility. But it seems like to me that the lightweight piston's aluminum too, so it's going to wear just like the, maybe not as much as the solid piston would wear. But and then the other thing that everybody says is to make it out of graphite. That is not an option for this engine, but that is an option. So anyway, with that, you know, if I can get this whole thing complete, then somehow I have to figure out what to do with the water situation. Somehow, I guess I'm going to have to build a tank out here and figure out some way. I guess the heat will pump the water, but I think maybe you need some way to pump the water. Let's see what else. I made this housing off camera too. It has two bushings inside. And what I did a little different, this push rod is supposed to be, this push rod is 1/8 of an inch now, but it's supposed to be 3/32, which is really, really, really tiny. So I was able to use a 440 thread on the 1/8 inch, so that's what I did, rather than go to a tinier thread. So hopefully that works out okay. The bushings ended up to be a lot thinner, but that's okay. And then this little gadget up here comes out, and you can oil this. And that brings me to one other thing. This tube right here has got a bushing in each end of it, but it needs a little oil hole right in the top. So I'll have to put that on the drill press and just make maybe take a center drill and just the point of it to make a tiny oil hole in here. So that is an update on the engine. Okay, so you can see I've just got it mounted temporarily to a block of aluminum. I got lots of this stuff laying around the shop that somebody gave me. So I temporarily mounted it to this block of aluminum. So this may not be the permanent mount for it, but I needed some way to get it mounted so I can assemble it, look at it, and probably I don't have any room underneath the chamber. I'd have to have an awful low flame under here. So I don't know how that's going to work out. It may not work with this block of aluminum. We may need more space under here, or some way to this block of aluminum to be shorter so we could put an alcohol lamp or something under here to run the motor. But there wasn't too many things that were silver soldered. I silver soldered the cap onto the chamber because this gets hot. And I also I had to be careful because there's one item inside at the end of the chamber, the splice ring that I silver soldered, because it was gonna be hidden, and I couldn't very well soft solder it. So because when I soft soldered the rest of this stuff, that would have melted the solder on that. So that was silver soldered. And also the other thing that was silver soldered was the flange on this tube here. And that was a little tricky because what I wanted to do was make the tube, put the bushings in it, ream it, and get it all set up. But the bushings, actually these bushings should be press fit in here. And I think the plan calls for Loctite. But the problem is, if you Loctite the bushings in there, then you silver solder this thing onto here, then the Loctite's going to come loose. So that's not going to work very well. So it was a little tricky. But that said, you know, I had to hand ream it, is what I had to do. If I had it to do over again, I would have pressed these bushings in here. Then I could have put this on the lathe, reamed it, put it in here, and silver soldered it, and we would have been done. Anyway, that's that. So that gives you an overview of where we're at. So I'll call off now, and I think I'll probably do the rest of these little small parts here and get the engine to run before we come back with a final video. So that's it for now. Thanks for watching. I'll bring you back later